now that we know how to build performance charts and we have some other tools under our belt, let's look at some of the most important metrics that we can use to determine whether or not we're under contention, okay? And how we analyze these charts to give us some actions. Let's have a look. The key factors that can affect virtual machine and application performance, and then utilizing those performance charts to help us to improve performance. So of course it's important that we understand how to look at these particular tools and how we interpret data from these tools. Looking at, for example, advanced performance charts, looking at CPU usage. CPU usage is an important thing. Understanding what portion of an ESXi host's total CPU are my virtual machines using? Is a virtual machine that has a huge number of vCPUs available to it not actually utilizing very much CPU at all? Looking at Task Manager and asking Task Manager, hey, am I pegged at 100% CPU? Is there something wrong with an application, or do I genuinely not have enough CPU allocated to the VM? All of these things can give us actions, can be actionable for us. Hey, let's add more CPU to a particular VM. Let's vMotion a virtual machine so that I have room on an ESXi host to run the VMs that in a state where stuff isn't under contention. Let's have a look at an ESXi host and look at individual VMs, okay? So you'll notice in here that we have a stacked graph per VM. And we're looking at ESXi 03 here. We can see the usage, which is an average percentage, okay? And we are looking at the total CPU utilization across two sockets, 200%, right? So you can now see that, hey, you know what? I actually have some spikes of total CPU utilization. Now, I don't think that's a bad thing to have a spike, as long as I'm not continuously running up at the top, things look pretty good, okay? But you'll notice here that, what is this value? There was some continuous usage for a period right through here at something like 125%. So that looks like out of the two sockets. So that looks like, I don't know, a total of maybe 60%, 65%. 66% utilization, right? If I'm asked to run more workloads on this host, will I get to a point where I'm having some issues? Okay, so you can use this to see whether or not I have VMs themselves that are CPU constrained. Look at this individual VM. Plex Media Server right here. The latest value, the maximum, is at 100% total utilization, okay? The ESXi host itself is here, a maximum utilization of 81% with an average of 22%. Well, okay, so this VM may need some more virtual CPU, this Plex Media Server, but I also can look at this average saying, hey, on average, I'm using 31%. It's up to you to say, hey, do I ever want to hit 100% peak utilization in an individual VM? Does that mean that somebody is hurting for performance at least some part of the day? Maybe, looking at this chart, it tells me that I have a VM that itself is CPU constrained and I need to dedicate more resources to my Plex Media Server. We can also look at individual VMs and notice that we have some CPU constraints, okay? So if I am looking at not just utilization, but a value called CPU ready. Now, I had mentioned CPU ready earlier, and I described it as a point where the virtual CPU running in the VM wants its thread scheduled and executed, but the ESXi host cannot find a physical core on which to execute that thread. That's the definition of CPU ready. What I would like to see is very low CPU ready, but you'll notice here that I have, here's my Plex Media Server again, a spike in CPU ready. And this is telling me another indication that my ESXi host itself is having a hard time executing CPU. Now, in this case, I am measuring readiness as a percentage. Okay? The value or the counter in ESXi that shows you CPU ready as a percentage is actually called readiness. Okay? CPU ready as a counter is measured in milliseconds. How much time over the last interval was spent in the CPU ready state. Okay? So in this case, yeah, there was a point where ESXi was under contention, and perhaps migrating this virtual machine to another ESXi host would have alleviated that pressure and had lower CPU ready values. And when I have a CPU ready value or readiness value over about 5% per core, I know that I might be under some contention. Okay? Let's look at memory-constrained virtual machines. And when we look at your virtual machines, we can tell whether or not the VMs themselves have been given an appropriate amount of RAM by your ESXi host. In this case, we're looking at 4 different counters: active, ballooned, consumed, and granted. Active being memory that has been touched by ESXi or by the VM in the last 60 seconds. Ballooned being memory that had once been granted and consumed by ESXi or granted by ESXi, but then ESXi asked for it back. Consumed is the total amount of RAM that is currently being consumed. This is active memory as well as idle memory. And then granted, this is total amount of memory that we've actually granted to that host for use. Not that it's actually used it or consumed it yet, but that we've granted. Now, seeing the amount granted being the full allocation, that's a really great thing. Seeing consumed here at only 2 out of the 8 gigs tells me, hey, maybe that this particular virtual machine didn't actually need all of that RAM. Okay? So I can look at this, and if I find that my ESXi host itself is under pressure for memory, maybe I had some ballooned memory. Here I don't, but maybe I had some ballooned memory. That tells me that other VMs are starving for RAM on this ESXi host as well, that maybe I can reduce this memory allocation and give some of that memory to other VMs. Okay. Now, if we've consumed that entire allocation, we might be memory constrained. Think about increasing the memory size. Look at this particular VM where I've consumed all 2 gigs of this VM at this point. And we can see that this is constantly high right here. This is telling me that my VM itself is constrained for RAM. I could probably see the same information if I go into the VM and look at perfmon or look at the task manager within this Windows 10 starved virtual machine. Okay? So we can see that maybe increasing the memory allocation can alleviate some of that pressure, and the VM and its applications would perform better. Now, looking at hosts, how do I know if my hosts themselves have enough memory to be able to accommodate the virtual machines that I've powered on? Well, the most important metric that we can look at here is ballooned and swapping. Any evidence of this is an indication that we might be memory constrained. So you'll notice here, right around this area here, I've got some, let's see here, the black one is ballooned, right? And the red one is swap. Even though the values appear to be low, okay, it does mean that some virtual machines at that point didn't get the RAM that they asked for. Okay, and this is evidence that I've consumed all the RAM on the ESXi host, and that maybe I either need to add more RAM or add more hosts, or turn on cluster features like vSphere DRS. Now let's talk about disks, because we know that storage is often a limiting factor in our environments in terms of performance, especially if we haven't upgraded to solid-state devices yet. Okay? So there are a couple of performance metrics that we want to look at for disk-constrained VMs. We want to look at the read and write rate, okay? How fast data is being read and how fast it's being written. But more importantly, we want to look at read and write latency. That is, as ESXi attempts to execute a SCSI command against a device, that command is being executed, a read or a write, and then returned the result to ESXi. That's round-trip latency, okay? And we can monitor that through the performance charts. Now, there are two different important metrics around latency. That is, the first one, kernel command latency. How long does it take ESXi to execute a SCSI command? Okay, ESXi obviously relies on CPU to do these sorts of things. Okay, if CPU utilization is too high, then ESXi is going to have a hard time executing SCSI commands. Now, I can tell you that ESXi is really, really good at executing SCSI commands. So really, any latency introduced by the hypervisor is a sign that the hypervisor itself is under contention. We say any high numbers greater than 2 or 3 milliseconds represents an overworked array or host. I gotta tell you, if I saw 2 or 3 milliseconds, I would know that my host was having problems. I would like to see this well less than 1 millisecond. Now, where latency is typically introduced in the environment is the physical device command latency, the average time that the physical device takes to complete a SCSI command. Okay, that's I've executed the SCSI command. Let's send it off to the storage array to be worked on and get the result back. Now, those results will really depend on the capabilities of the array, whether or not we have spinning hard disks where we'd like to see numbers under about 15 milliseconds, or we have solid state devices where we would like to see numbers around the 1 or 2 millisecond time frame. Certainly 3 or 4 milliseconds is high and is an indication that your storage array itself is under contention. I've got too many ESXi hosts and too many virtual machines trying to execute too many IOPS against the storage itself. Now, when it comes to networking, this is a really easy thing to measure, right? Because we know how fast our networks are. 10 gigabit, 1 gigabit, 100 gigabit, whatever it might be. So I know the total capabilities. What I'm really looking for are dropped packets. Any packets that are dropped as we attempt to send them to the network or we attempt to retrieve them from the network are a sign that there's something wrong on the network. Now, one of the things that we can do to really improve network performance is to ensure that each of the virtual NICs is utilizing the VMXNet 3 adapter. Okay? This allows each virtual NIC to communicate directly with the network adapter, bypassing the hypervisor stack. Okay? So this really makes that hypervisor overhead go away and makes the network much more efficient. Okay? But we can tell if especially if we've got VMXNet 3, if we still see drop packets, that we've got a problem on the network by looking at dropped packets. So that gives us CPU metrics to look at, CPU ready, memory metrics to look at, ballooning and swapping, disk metrics to look at, high levels of physical device command latency, and network metrics to look at, dropped packets. Those are the basics. If you cover those bases, you're in pretty good shape. Let's play with this a little bit here in the lab and look at lab number 23 as we use performance metrics, look at performance metrics when we're running those CPU busy tasks. It's a fun lab, so I hope you enjoy it. And that does it for our little lesson on monitoring the environment. Now, if you want a much deeper dive into the hardware, the Optimize and Scale class does this for like half the week. Looks at performance monitoring, really understanding in a very deep way how our virtual resources interact with the physical resources. So I hope you enjoyed this, and we'll see you back when we look at lesson number 5 on using alarms.